Welcome, everybody, to our webinar on marketing optimization. I'm Gary Robinson, the Chief Operating Officer of Lityx, who's hosting today's presentation. Last month, we presented Optimization Explained Simply in an effort to introduce this very valuable solution to a wider audience and explain what it is, how you do it, using terms and examples everyone can understand. Today, we continue the conversation and show a hands-on demonstration of how complicated marketing optimization problems can easily be solved using a non-technical advanced analytic tool called Lityx IQ. We will revisit the previous content in the introduction to the topic, and then we're going to quickly move to the demo. But first, just a couple of small housekeeping items. All attendees will be muted throughout this webinar. If you think of a question, please use the question button, and we will either answer these at the end of the webinar or provide you a response shortly after. You will also see a Rate This button. We would love it if you would provide your rating of the presentation and give us feedback on what you thought of it. And please note that your viewer can be expanded to full screen by clicking on the rectangle icon in the bottom right corner of the viewer. I encourage you all to do this so the presentation is as clear as possible. And then one last thing, the PowerPoint presentation that you're going to see will be available in the attachments, and this webinar also will be available on demand after it's finished. So if there are any colleagues or friends that you think would benefit from seeing this, just send them to the link that you used today. With that then, I'd like to introduce the presenter for today's webinar, Paul Maiste. Paul is the President and CEO of Lityx and has 25 years experience providing business intelligence, analytics, and management consulting services. Paul's experience includes 7 years at PricewaterhouseCoopers, where he led the firm's CRM-focused analytics and data mining practice and was a global alliance manager in the relationship marketing and data warehousing practices. Paul holds a BS degree in mathematics from Loyola College in Maryland and a Ph.D. in statistics from North Carolina State University. So with that, I turn you over to Paul. Paul?
Okay, thanks, Gary. Good afternoon to everyone. Like Gary, I want to thank you for joining today and hope that by the end of this, you'll think I've been able to provide you an informative session. As Gary mentioned last month, I gave a webinar explaining sort of the broad concept of marketing optimization, talked about its potential impact on the business, and for the most of that webinar, provided what I might call a simple recipe book for how to begin planning and solving optimization problems. If you were there for that webinar, I used a couple of examples to walk through those concepts. What I'm going to do today is spend a little bit of time here up front reminding those who were in last month's webinar some of the main things we talked about. Just run through a few PowerPoint slides fairly quickly. But that will also be good background for those who were not there for the first part of the series. The main objective today, though, is to give you a live demonstration and hopefully show you that as complex as it might seem, as important as the problems are that we're solving with marketing optimization, it doesn't have to be backbreaking, months-long, mathematically intensive exercise. You can do it. You can get very strong, granular results, and also have tremendous impact. So let me start walking you through again a few slides to remind us some of the things we walked through last time. Real quickly, I showed this last time. First, a perspective on where optimization fits into the overall analytics spectrum. And I pulled this from Gartner because what I like about it is not only does it show the progression of analytic steps that an organization might take as they move from more kind of looking backwards and descriptive analytics up through optimization, but also so how they build upon each other and feed into each other. So clearly, again, optimization is on the upper right side of this, so the business value is very high. And as always, no surprise, there's no free lunch these days, and so the complexity that goes along with that is also on the high side. What's not as clear in this chart, but I did point out in the first webinar, is that these different analytic techniques are not necessarily in silos. They often work well, in fact work best when they're used in conjunction. Many of our clients that we've done optimization work for, we've done that right alongside of predictive analytics, for example, where a model might feed into optimization. So, in fact, one of our live demonstrations, I'll walk through an example of using modeling scores as a part of an optimization process. I also give it a quick overview of the potential impact of optimization on various marketing metrics, things that we can affect with optimization. And of course, the things we can affect are all over the place. Response rate, website conversions, annual revenue. For example, one client we have been working with through optimization and also tied into predictive analytics that we did for them as well, we were able to impact response rate up 90%. I think it was even a little bit more than 90%, using a combination of predictive and optimization techniques. Another, actually, retailer that we had worked with, we were able to move to about a 50% lower cost per lead. So whether it's those two metrics or any others you can think of that a marketer is paying attention to, can have significant impact if you can do marketing optimization well. When it comes to the complexity of the problem, I use the analogy of the Milky Way as again, sort of a way to get across how many possible solutions or how complex these kind of problems can be. Kind of thought about each star out there as one possible solution to the marketing optimization problem. And our goal as the analyst is to kind of weed through all these possibilities and pick out the best, the most optimal star. And obviously, it's a pretty daunting task. You know, I used that word last time. The example I was walking through last time as I kind of showed this slide literally had billions of possible solutions. So it's daunting. A typical approach that a marketer is going to use without more sophisticated tools and techniques is to say, you know, let's whittle down the problem. Let's make it a little bit simpler. Let's focus on just a certain segment or a certain geography maybe, and kind of whittle down that solution space to a much smaller set. So for sure, that makes the problem a lot easier to solve, but also just as certainly, it's going to lead us to having a suboptimal solution, something that's not as good as we could do. And very often, it's not just suboptimal in a minor way. It can be a very major impact, a major hit on the result that we get. So I had then kind of moved forward into the techniques that we rely on to get beyond this simplification that we often take. We'll really rely on iteratively searching through this massive solution space, search through these potential solutions, disqualifying solutions that don't make sense, don't meet our criteria or our constraints, and narrow down the possible set of solutions down to smaller and smaller sets as it goes through. The goal here in the webinar series is not really to focus on the mathematical details that are behind this, but we really want to focus on what the user needs to do to set this problem up, and that's what we spent last webinar doing, and today I want to really kind of move beyond that and actually show you some examples of how it's done. So to actually start moving forward and solving problems, I walked through 4 key steps in doing that. And last time I walked through detailed examples and spent some time on each of these and looked at real data. It's kind of sample, but some real data as we went through. This time, let me just summarize what those steps were. So really, it's on the screen here. So it's on us to describe the problem, figure out what our supporting data is, and get access to that. Document our objectives, what are our constraints, the business constraints that we have to live with, as well as what's the final decision that we need to make. If we can do all these things well and do them consistently, then the math can get going and do the hard work for us. So also last time I had introduced kind of a toy problem and had applied these concepts to that problem simply through kind of slideware, kind of walk through some PowerPoint background on how to solve a problem. It was this sales rep optimization problem. So the goal here was to optimize the effort made in performing outbound, say, sales and marketing calls. And the roadmap that we wanted at the end was a plan for how many calls each inside sales rep would make within, various target segments and multiple months and so on. So what's the right optimal calling plan? That was our goal. And to get there, as part of that setup process, we walked through these 4 or 5 steps, laid out some of the key KPIs, total calls, sort of total responses that we would get from those calls, what were the sales we'd make, and so on. And we had a number of levers, as I had called them. You can also think of these as dimensions of our business. So we want to do this across different products and different time periods and different segments. We also discussed that there are a number of constraints that sort of go along for the ride in order for us to solve this problem in a way that the business can implement. For example, one of those constraints is sort of a budget and an effort constraint that limits the total number of calls we can make. We just can't, we have a team of folks and they can't call an infinite number of people. So there's some limit, budget-wise and time-wise, to how many calls we can make. So hard business constraints came into play there as well. The data that we had included things like sales rep and their association with different products and segments, for example, as well as historical views of response rate and average sale size. At the end of the day, our goal was, as I said before, to decide how many calls each of those reps should make into the various products segments over different periods. The result, again, that I showed last time was simply a very high-level view of those key metrics. If we were to implement the optimal solution, here's what we could expect. So today, the goal is to show you a bit more than this, and we want to define a couple of new problems, real problems. We're going to have some real data to walk through, set them up here, last couple of slides in PowerPoint coming up, and then walk through some solutions to them and actually show you some live runs of them in our Optimize IQ solution within our Lityx IQ platform. Okay, so with that then, let's move ahead and set up a couple of real problems. And again, I'll then switch over into a live demo. The first one we'll spend a little time with is related to online media optimization, specifically optimizing the purchase of banner ad impressions. And the second one, which we'll get to in just a second here, relates to direct mail optimization in the retail industry. So first, for the online banner optimization, a little bit of background on what we're trying to do here. We want to optimize really a media plan. Okay, what's the right optimal media plan, buying decisions in terms of purchasing impressions for a variety of online ad placements. What we want to do to get us there is incorporate potentially a level of testing into that plan, maybe different creative sets that we have and we want to test out in the market. A lot of different objectives that we might have. We want to obviously improve things like conversion rates and the number of people that we can convert, decrease things like cost per conversion. So a lot of objectives or KPIs that we might focus on. And again, at the end of the day, the outputs we're looking for is the optimal media plan. Okay, what should we buy? And if we break that down into the steps, the setup steps that we've walked through, KPIs, as I mentioned, conversion rate, things like click-through rate, cost per conversion, cost per click, total conversions. Probably others would be important to us as well. For example, overall budget for solving the problem. But some of our core KPIs that we want to try and affect. In this example, the levers or business dimensions that we'll play with include things like the site category that we'd be purchasing the media from, creative styles. There are 6 different creative styles that we can use in our online ad placement, different geographies, different sites we can put the placements, as well as ad size and type. Okay, so these are the levers that we will play around with and optimize into. Again, we're always going to have business constraints when it comes to a marketing optimization problem. So certainly we're going to have a budget restriction. Okay, there's some limit to how much we are willing to put into this channel, into this media buying plan. So we're going to have an overall budget restriction that we'll look at. We also may have some kind of geographic dispersion consideration. Testing needs, I mentioned on the previous slide. For the different creative that we have access to, we want to not necessarily just kind of focus on one or two of those that have appeared strongest in the past, but we want to put them all out into market, at least to some extent, so we can gather some data and maybe do some analysis down the road. In this example, the data that we'll use is relatively simplistic in a sense. We'll be using actual prior results from prior similar campaigns that we've run. Okay, so those will be the driving force for the decisions we're about to make to optimize future media buying plans. And finally, the results that we're looking for, again, that media plan from a numeric standpoint is the number of impressions that we're going to buy within these different combinations of business dimensions that we have. Okay, so keep this one in mind. Just to finish walking through the background of the two examples I'll demonstrate to you, let me also walk you through the retail direct mail optimization problem. So here, very different channel, obviously, direct mail. Think about a retailer with multiple locations, and they are looking to put direct mail out at various points in their marketing calendar. And they want to only market within their footprint, of course. And the final decision, really, what they're looking to get at is what's the optimal targeting plan. So for a prospecting campaign, you have a list of prospects that are available to you. The question is, which one should I target? Target some, and up to how much budget I have, and I'm not going to be able to target the rest. So what is that optimal plan? Who should I target, and who should I not target for this campaign? So this example is interesting in the sense that we have incorporated results from our predictive model into the optimization process. So a model that was built also using the PredictIQ solution in our platform, a clone-like model that incorporates things like demographics, household and individual demographics, census data, things like distance and drive time to the retail location, and so on. So anyway, well incorporated into the optimization problem. So again, here, simplistic in terms of KPIs, the real focus is response rate. We're trying to drive up response rate. And so the combination of model score, which is a prediction of response rate, really kind of go hand in hand here. This is an interesting and different problem compared to the sales rep optimization and the banner ad optimization, because in this case, the levers or dimensions really are the unique individuals. Okay, so in other words, the decisions we're making are at the level of an individual or an individual household. Okay, do we target or not target that individual? And you can see the decision variable there is it's a 1-0 binary. We're either targeting or not targeting each individual in our prospect list. Lots of constraints go along with this. We have location-specific direct mail quantities to worry about. We want to, sort of like I mentioned, putting some in-market testing in with different creatives in the online banner example. In this case, we want to also throw some volume out in our direct mail that's kind of cross-decile random sampling, so that we can collect data across our model deciles and use that either for analysis and performance metrics on our model, or for later building and refining that model down the road. We want to limit the number of mail pieces per quarter to each individual. So this is sort of a contact rules constraint. We may not, for example, want to contact too many people more than once per quarter. And in addition to that, there's a fairly complex constraint that we want to ensure that a single individual is not mailed more than one piece in the cases where that person might be in the footprint of multiple retail stores. Okay, so we don't want them getting 5 pieces if they happen to be in the footprint of 5 stores. So to limit 1 per person. Okay, and as I mentioned, the data to support this includes modeling information, so model scores and deciles, as well as the store and location that individuals are associated with, what footprints are they in, and also data like how many, through our campaign tracking systems, how many times has each of those individuals been mailed in the prior few months. Okay, so let me use that and jump over into the Lytyx IQ platform and log myself in here. I got that right. And first, I'll walk through some examples of the media buying, online banner ad optimization. And real quickly for that problem, I'm going to stay in the data manager solution here within the platform and give you a brief view of the simple data set that will be used as the backbone for solving this problem. So what you can see here are some historical results for different placements that have been made, how many impressions, how many clicks, what was the creative that was used, what was the category of the site. We have some geographic information. Placement was in a local geography like Atlanta or Los Angeles or national geography, different sites themselves, and so on, including what is the available inventory for purchasing impressions in the upcoming period. Okay, so that represents the data that will serve our purpose for this problem for optimization. All right, so with that, I'm going to jump over into our optimized IQ solution. And notice that when I come over here, we have a list of scenarios. So obviously, as we've run this in the past and in preparation for today's webinar, I've set up a number of what we call scenarios, and kind of think of them as what-if games that we can play with our data to try out different settings and constraints and objectives that we might have. And so right now I have 4 scenarios here. And just based on the way they're labeled, you can notice that they are all focused on a different metric. All right, so the first scenario here, we'll drill down and take a closer look at all of these, is a scenario that's set up to try and find a media buying plan that will maximize our conversion rate. So if conversion rate was the key of all these KPIs we have out there, if that was the key one that we want to focus on and focus our media buying plan on, then that'd be the scenario we pay more attention to. But maximizing conversion rate is not the only way to go about optimizing a media plan. We can maximize conversions, for example, maybe maximize click-through rate, CTR, maybe on the other side of things, minimize cost per conversion. Okay, so a lot of things that we can focus our plan on. Now, in the platform here, tying that to a data set is how data makes its way from the data set that I just walked through briefly and browsed in the data manager and ties it into our optimization problem here. So essentially, all the dimensions and pieces of data that come to play for us to solve our optimization problem are connected to that data set. So you may have noticed as I was in the data manager, the data set was called OLA, historical data. So we're connecting into that here in the Optimized IQ platform and associating the various dimensions and pieces of data in our optimization problem with variables from that data set. Okay, so everything's driven from this data set that we looked at. Okay, so let me walk you through one of these scenarios. I'll pick this first one here, maximize conversion rate. And let me show you, again, remember my goal here in this webinar is to walk you through a live demo, and as a part of that, really show you that solving problems with a platform like this can be very easy. It can help put in the background a lot of the more complex mathematical techniques and bring to the foreground the business concept. Okay, that's the setup and the planning. Make it very easy to do complex things like solve different problems with different objectives, add complex constraints, and so on. So in any case, setting up our optimization scenario or problem here, we certainly have to give it a goal, an objective, and what this scenario is doing, as I had already mentioned, based on its name, it is looking to maximize conversion rate. Okay, so the various KPIs that have been defined here, this is the one that I'm focusing on for this particular scenario. And the constraints that are in play for this scenario are in line with those 4 that I mentioned in the PowerPoint setup. Okay, so we have an overall budget constraint, for example, and just so you kind of see the background and what these constraints, the numbers behind this constraint, when we open it up, and we can notice that our budget restriction here is we want to ensure that our budget spent as we solve this problem is between $400,000 and $600,000. Okay, so that's our overall budget range that we want to stay within. And essentially what I'm doing down here is saying that this constraint applies to all the levels of all 5 of our dimensions combined, okay, rolled up into one. So it's one big overall budget constraint. Okay. We also had that constraint regarding creative testing. Okay, so we have 6 different pieces of creative that we want to put out into market. And again, the idea here is even if one of them is by far and away the strongest, what I'm saying here is restrict the solution to not just put that creative out there, but kind of spread it out a little bit so we can at least get some testing data for across creative. So anyway, this constraint is focused on the total impressions KPI or metric. And what we're saying here is we want to ensure that the percentage of total impressions that we purchase is at least 3, so at least 3% for each of the 6 creative, okay, that we have. Okay, combined over all the other dimensions, but separately for each of these 6 creative. Okay, so it's really 6 constraints rolled up into one. Okay, each of those will be ensured to have at least 3% of impressions assigned. From a geographical standpoint, as I mentioned, we have 3 regions. We have an Atlanta and a Los Angeles, as well as a national region here. And what we'd like to do is ensure, just from a segmentation and regional targeting perspective, ensure that at least 20% of our budget is assigned to our localities, Atlanta and Los Angeles. Okay, so percentage budget greater than or equal to 20 applied to Atlanta and Los Angeles separately. And finally, important constraint here is our inventory, our media inventory constraint. So in this case, what we're saying is that for all levels separately of all of our dimensions, we want to, we certainly have to restrict our problem that we don't want the answer to come back and say buy more impressions than are available for that combination of dimensions and levels. So I think this is available inventory. We need to make sure that our media buying plan is within that restriction. So total impressions is less than or equal to the inventory amount, okay, for all levels, but separately for all of our levels within the 5 dimensions. Okay. So that's really what all it takes, once we get the data in place to set up an optimization problem here. And you can see that I have set up 4 such problems. The only difference with the other 3 here that we didn't walk through is just the objective function part of it. So they all are set up with the same constraints. Okay, so all of these have been pre-run. And I will create a new scenario in just a bit and kind of show you how that's done and while we might look at some other scenarios here to play some what-if games. But let me go ahead and show you some of the analysis that we might do on the back end. So, we've run these scenarios, we've attempted to maximize conversion rate or maybe get a media plan that maximizes click-through rate. So obviously the next thing we'd want to do is come in and take a look at some of the results. So if I focus again on our maximized conversion rate scenario, we may ask some simple questions, like let's get an overall summary of our, maybe a variety of our metrics here. So come in and pick a few of these. And so what this is telling me is that if I follow the recommended optimal media plan that will maximize conversion rate, these are some of the metrics I'd expect to see if that plan were implemented. The budget range of 400 to 600,000 looks like we're looking to spend on the lower side of that for 400,000. You can expect a conversion rate of .0000029. Cost per conversion of 145.74 with an overall click-through rate of 0.14% and 134,000 and some change in clicks. Okay, so that gives us sort of an overall view of what we can expect if we were to implement the plan behind maximizing conversion rate. And of course, we can break that down by various other dimensions that we have as well. So for example, if I want to take a look at budget by region. All right, so here I kind of drill down a little bit and say, looks like we're spending after putting most of our budget into our local regions, Atlanta and Los Angeles, so that 20% that we allocated, we're actually well outspent at the minimum of 20%. Still a little bit being spent in our national regions, so maybe a sign of more local advertising to more local sites doing a better job for us in terms of conversion rate. We may also look at it by, let's say, size and type and how we're going to spend optimally in order to maximize conversion rate on this particular dimension. So we have large, other, small, and video. Looks like we're putting most of our budget into that small ad category. By far and away, less budget on the video category. I want to look at conversion rate by category and see how that breaks out as well. Clearly, looks like we're putting most of our budget into that small size category because of its higher conversion rate that we can expect. Okay, so a lot we can do in terms of analyzing the results that come back from our optimization, but not just for a single scenario at a time. They're really meant to be comparisons against each other, sort of, again, what-if games and look at one result compared to another. So if I come in here and do a scenario comparison, we can drill down a little bit further, maybe compare our 4 scenarios and look at an overall summary, for example, maybe total conversions. Okay, what's always interesting here is that obviously the scenario that we set up to maximize conversions should be and is the one in this case that actually provides us a plan that gives us the most possible conversions. You can expect 2,758 under that scenario. But it's always interesting when you look at and start comparing the differences here, because it's not usually the case that these scenarios will kind of give it the exact same plan. There's always trade-offs that are being made. So maximizing conversions may give us a trade-off, and we can kind of see that here with respect to click-through rate. Okay, so if I want to maximize click-through rate, I can only expect to get 2,591 conversions. I'll maximize click-through rate, but I'm trading off a little bit in terms of conversion bucket. So really is important to get sort of business metrics, those core KPIs down, because they don't all fall in line with each other. There's trade-offs to be made, and results like this show you pretty clearly what those trade-offs would be. Again, drilling down a little bit, I can look at maybe the budget we'd be spending by region for each of these scenarios and how that might shape up from one of our objectives to another. So a couple of differences here. So it looks like we want to put more into Los Angeles than into the Atlanta region if I want to maximize conversions, but slightly tipped in the other direction if my goal was to minimize cost per click. And of course, I can drill into other metrics as well. Okay, so in the progression that we're making here as an analyst, we've set up some scenarios and created some data from historical results that we've had. We have created constraints. We've run some scenarios and starting to look at and compare. Kind of a key next step is we ultimately will make a business decision here. We need a media buying plan for the next upcoming period. And at the end of the day, we're going to pick the KPI, pick the plan that kind of most reflects our marketing objectives. And let's say for the sake of argument here that In this case, it's the maximized conversion rate metric. What we would do next is go ahead and take a look at what we might call the MAP, the detailed media plan that comes out of this. Okay, so up to this point, we just kind of looked at some high-level summaries and high-level metrics, and that's all good stuff to look at. But at the end of the day, we need a plan. And so the final result here that comes back to us is the actual media buying plan. So if I look in here and then sort this on advertising impressions, this is essentially the result for the decision variable, the number of impressions to buy at each combination of our various dimensions and their levels. Okay, so that is our media buying plan. And of course, we can ship this off to our media buying vendor, as well as a number of other metrics that we can expect to see as a result of this plan. Okay, so that's good stuff. Let's say we want to go a little bit further and take a look at our maximized conversion rate. And you remember we had that $400,000 budget. What if we want to, or maybe our marketing manager comes to us and says, tell me what would happen, how would things look if I told you we had 25% less budget to spend? Okay, I want to play a little what if game. And the manager needs to know that, right? What's the decision? Spend less budget, clearly we can expect less results in certain areas, worse results in certain areas, but what's the trade-off we're making? And so what we can do real easily here is set up a new scenario that reflects this different budget constraint that we have. I don't want to change what we currently have, so I'm going to make a copy of our maximized conversion rate scenario and maybe call it 25% less budget. And now go into that one and edit the settings. And the one change we're making, of course, is I want to go over to the overall budget constraint. And instead of using 400,000, I'll plug in 300,000, so as a lower bound. So 100,000 potentially less budget. Save that change. And so now I have a fifth scenario here. I want to run it. Okay, so and the other scenarios here were pre-run for the sake of time in our webinar, but let me go ahead and run this one as we talk here, and I'll open the console to watch our progress. And so essentially, again, what we're doing here is asking that question, what are the trade-offs that are being made if we reduce budget by 25%? And if you think about it, that's not the only question like that we might be asked by our manager or might want to answer. For example, the creative restriction that we had, putting at least 3% of our budget spend into each of those creative. The question is, what is this testing strategy, this testing one strategy? What's it costing us? What's the trade-off? What if we didn't have that constraint in place? What will we gain? Any constraint that we use on a problem is, if anything, going to cause a degradation in our overall results. Okay, so our scenario is finished running. I'm now going to come back into our compare scenarios, and we have 5 up here now, but I really want to just focus on the first 2. So let me pick those 2 and take a look at, let's say, conversion rate as a comparison metric. Remember, our goal in both of these problems was to maximize conversion rate, just with different size budgets. And so you can see what, we can start talking about that trade-off now. So our red bar here is our scenario, our result, our plan if we were to use 25% less budget. And not unexpectedly, our conversion rate goes up. Okay, so we can move from a 0.29 to a 0.41. But other metrics may not fare as well. So for example, spending less money, getting a higher conversion rate, but what about the total number of conversions I can expect? Okay, so I was looking at 2,745 with the full budget, a reduced budget 2,481, so about 150 or so, actually, about 150 or so, 250 or so fewer conversions. And so this is the kind of trade-off information I'd take back to my boss and say, 25% less budget, we can do that. You can expect to get 2,500 fewer conversions, but get a higher conversion rate out of it. Okay, so that's where the decision has to be made. Okay, in the minutes we have left, I do want to jump over to the other problem that I had introduced, the retail direct mail optimization. Again, very different animal in terms of channel and style of problem and level of optimization, but let me give you a quick overview of this one. It's a much larger and more complex problem in the sense that it's, as I mentioned, an optimization at the individual household level. Okay, so we're making binary 1-0 target or no target decisions for thousands and likely hundreds of thousands, maybe even millions of prospects. In this case, the data set includes things like a unique key as our dimension that represents each unique individual. And again, real important key thing here is we have on this data set that will drive our optimization both a decile and a score that came from the output of a predictive analytics model. So each of our prospects has a response rate model score as well as a decile that they fall into. And we'll see actually how that plays a role in our optimization setup. Okay, so for this particular problem, we have just a single data set, a single scenario here. And so let me go ahead and show you what's incorporated. So we have an objective function, maximize total score. That's in essence looking to maximize response rate because our model score is the prediction of response rate. And in addition to that, we have constraints along the lines of what I walked through in the PowerPoint. So we want to meet requested mailing quantities by location or by retail store. I have a couple of constraints in here that are focused on cross-decile testing. So this first one here is saying for deciles 1 through 5, let's ensure that the percentage of actual mail quantity that goes out, okay, based on our recommended optimal plan, puts at least 2% of that quantity into each of these 5 deciles. Okay. Same thing for deciles 6 through 10, but we're not putting as much effort or as much testing into those. So same idea, deciles 6 through 10 here, but let's only ensure that 0.3% of our overall mail quantity goes into each of those deciles. It's very easy to control and ensure that at least some of the mail quantity, the mail plan, hits lower deciles. In terms of a constraint that we can use to control overall mail number of times an individual has been mailed to over the past quarter is this one here. So I can set up, make sure that the percentage of actual mail quantity is not more than 10%, and use kind of assign that to people who have been mailed one time before. Okay, for that subset, I call this an attribute in the solution here. For that subset of people who are mailed one time before, they cannot represent more than 10% of the actual mail quantity. Okay, so we're allowing some people to be mailed, probably the strongest prospects to be mailed multiple times in a quarter, but I'm limiting that. And in fact, for those who may have been mailed multiple times in the past, this next constraint ensures that we don't touch any of those in this new mail plan. Okay, so no mail quantity to anyone who's been mailed 2, 3, or 4 prior times. Okay, and the last constraint here is that one that can really turn this into an extremely complex problem from a mathematical standpoint, and that is the assurance that we don't contact a single individual, more than once in this mail plan. Okay, again, the backdrop to that is it may be that a single individual is in the footprint of multiple stores, but we don't want them getting 2, 3, 4, just because they're a strong prospect to get multiple mailings from multiple stores at the same time. So this one says that the actual mail quantity can't be more than 1, right? You can mail a person once or 0 times. And this is based on all individuals, all separate individuals on their person ID attribute. Okay, quick review of results that we may look at as part of having run this and summary results that come back. We may look, for example, to break down what is the mail quantity that's been recommended by decile. So we can see decile 10, for example, our lowest decile, the worst of the worst prospects, but we are putting 378 mail quantity into that decile. So here's our decile plan in terms of prior times mailed. You can see that the result has ensured that we aren't mailing anyone who's been mailed 2 or 3 times before. Most of our mail is going to those who have not been mailed before, so fresh prospects. And final thing I wanted to show you for this particular example is coming back to that idea of a detailed output for the plan. What's the final plan that goes out the door here? And in this case, again, the detail behind this is a lot more detail, I suppose, a much bigger data set. Every individual, every unique key, every unique individual in our data set here has either a 1 or a 0 in this contact flag. Okay, targeting some folks, we're not targeting others. That plan is then shipped off to our direct mail vendor, and they execute against it. Okay, so this again is sort of the map to how to make this optimal result happen in market. Okay, that is all I have for you today. I hope it was informative. If you do have any questions, if we don't have time to answer them here today in the webinar, feel free to reach out to me, myself, or Gary, and definitely happy to talk to you about that. So thanks again, and have a great rest of your day.
One quick thing for the audience, if you'd please leave feedback, that would be great. We'd love to hear what you thought of it and any ways that we could improve it or if you liked it. So thanks, everybody.
Thank you.